Hello and welcome to the Erlang Solutions monthly webinar. My name is Martin Sumner and I'm the VP for the EMEA region here at Erlang Solutions. Today's webinar represents a continuation of a series of webinars we have been running across topics of interest in the world of Erlang and Elixir, and dealing with solutions generally based on the beam. Now today we will be talking about how the NHS is directly investing in a number of improvements to its use of the Riak database. We will detail some of those enhancements, such as improvements to anti-entropy and replication mechanisms, other improved efficiencies with the level backend, and the new ring configuration parameters. This is a live event, so please do excuse us should any technical issues crop up. But to start by telling you a bit about Erlang Solutions, we are a products and services oriented company. We are completely devoted to the Erlang and Elixir programming languages. We work with organizations and individuals using things based on the beam, and we help them evolve Erlang and Elixir, and we support them in their use of these technologies. Now, we are headquartered in London. We have offices in Stockholm, Krakow, Budapest, San Francisco. We work on projects across the globe and also develop Erlang-based products, some of whom include our Mongoose IM instant messaging platform and Wombat OAM, which is a monitoring and management technology for Erlang and Elixir systems. Now, I'm really pleased to say that our speaker today is Martin Sumner, a technical consultant at the National Health Service. Martin specifically focuses on designing and building systems for the NHS and provides the technical leadership for the large-scale spine core system, which is the central messaging and database solution for the NHS. We are indeed deeply privileged to have Martin speaking at the webinar today and telling us a bit about the latest technical accomplishments within the NHS. Now, please allow me to finish by saying you are very welcome to post questions throughout the duration of the webinar. You can use the chat facility on the webinar's interface for that purpose. Our speaker, Martin, will answer as many questions as time allows at the end of the webinar. We'll have a Q&A session. If any questions do go unanswered, you're welcome to raise them via email. My email address will be displayed in one of the final slides of the webinar. I would now like to hand over to Martin, who will be glad to start us off.
Okay, thank you for that introduction, Martin. So I'm going to talk a bit about Riak, our use of Riak in the NHS, and particularly around the new features that we're looking to add to Riak over the course of the next 6 to 12 months. For those unfamiliar with the NHS in England, we're the public health service, and the NHS is a relatively large institution. It's reputed to be the third largest employer in the world after the Indian Railways and the Chinese Army. So when we do centralize IT systems for the NHS, they're often of a significant scale for enterprises. And we have a number of systems that are currently using Riak, the primary one being the spine database that was talked about earlier. And across those systems, we have about 100 compute nodes running Riak in production, plus various other Riak nodes in reference environments and other test environments and this kind of stuff. Some of our largest clusters have around about 1 billion objects in them, and they tend to come with fairly stringent requirements around always-on availability. So, you know, zero downtime for change, 24/7 permanent availability. And you know, people do use these systems throughout the night. And you know, it's important to be available to be able to inform someone of a clinician of what adverse reactions the patient's had in the past, regardless of whether they're dealing with the patient at 9 o'clock in the morning or 2 o'clock on a Sunday morning. The reason for choosing Riak originally at the NHS was for that spine system, and it was very much focused on its availability capability to support our availability needs, but also on its durability of data. For the systems we run Riak on, generally speaking, there's a real importance that we never lose data, that any change given to us is always eventually made available to the users. And we don't lose any history of access to data or anything like that. So durability is really important as well as availability. And since we've been using Riak in production, I think probably the primary benefit we've gained from it has been around the long-term low cost of ownership. So although aspects of using Riak probably increased our development time and the time it took us to get to production, it runs for us at very low operational cost. So though we have hundreds of nodes in production, we don't have a large team of database administrators. And though we're running the system 24/7, we don't have to have Riak experts on hand at all times to deal with failure. Failure is generally dealt with automatically and can be handled in simple ways. So it's worked out very well for us so far. But now we have the changing circumstances with Riak's prime developer Basho no longer being available. And so we're in the NHS, we have to take some more responsibility for our Riak system going forward. For those that aren't familiar with Riak, I'm going to try and give like a 2-slide overview, which I'm sure will infuriate everyone who is familiar and leave anyone who isn't familiar fairly confused. So let's see how this goes. It's inspired by the Amazon Dynamo paper. I recommend you have a look at the paper. It interprets that, interprets that paper and produces the key values still written in Erlang that is able to scale out nicely. But one of the primary differences between Riak and other things that implement the Dynamo paper is that it protects from data loss on conflicts. So it doesn't use last write wins. And in the worst case scenario, it will provide back to the application both options. It doesn't make an automated choice on conflict unless you're using a specific data type, which can make that automated choice for you. So given that we run things at quite a large scale, the scale out was very attractive to us. Given that it handles failure quite efficiently, that was very attractive to us. But it was also very attractive that all of that came without risk of us losing data that we'd received. So it has a concept of a ring size. So the ring size represents how many individual databases exist within the cluster. So this is an example drawn up with a ring size of 16 vnodes, we call them. So effectively the cluster is running 16 separate databases, and those 16 separate databases are split around separate physical nodes. So here we're showing 6 separate physical nodes. Each are capable of running any one of those 16 vnodes. But the Riak core claim algorithm has distributed the active vnodes around so that each of the nodes is only ever running 2 or 3 of those vnodes. And when we take a key, that will and hash that key, it will be hashed to a given partition, and 3 consecutive vnodes numerically will be responsible for that partition. So highlighted are the vnodes 3, 4, and 5, which will handle a key that's hashed to partition 3. And those 3 nodes are split across 3 separate physical nodes so that we've got diversity and protection of that data. And should node 5 fail, it will still be stored in vnode 3, on node 4, and vnode 5, and node 6, but it needs a replacement for vnode 4 that was on node 5. And it can't, and so what it does, it asks the physical node that holds the next available vnode in the ring. So in this case, that's vnode 6 and physical node 1. It asks that physical node to start an instance of vnode 4 to replace the instance of vnode 4 that's been lost from node 5. And so now things will be stored still in vnodes 3, 4, and 5 for something hashed to partition 3. But that will now be on nodes 4, node 1, and node 6. And when node 5 recovers, node 1 will hand off or empty the contents that vnode 4 back into node 5, so it picks up any data that's missing. So in a sort of short time as possible, that's a sort of rough idea of how Riak works. And this distribution of active vnodes around the physical vnodes, whilst maintaining separation, physical separation, is what contributes to the availability and durability. And then as we add more nodes, those vnodes can be distributed further around, giving us the scale out characteristics. So this has worked very well for us, and where are the broad areas where we think things can be improved? Well, the big focus is for us is availability and durability, and there's some aspects of that where we feel we pay a slightly too high a cost of that. So I'll discuss the changes we're looking for there. Although almost all our use of the Riak databases is focused on gets and puts, so key gets and puts, so standard key value operations, we do in some clusters make significant important use of secondary indexes for things like tracing patients when we don't know the full details of the patient, and in particular their identifier number. So that's an important feature for us. And the nature of Riak means that there are sometimes windows when an inconsistency can occur in secondary index queries. And one of the areas where we're looking to improve is to look at the cause of those windows and see if we can narrow those windows down and the number of situations in which such sort of inconsistency windows occur. The third broad area is that the gets and puts are very, very important to us and must never fail. And we don't want the gets and puts to fail because something running secondary indexes has got out of hand, or some kind of background database process has gone out of hand. So we have a strict idea of how we want our workloads to be prioritized and what we're willing to sacrifice should there be contention. And so one of the areas for improvement we're looking for is how we can sort of enshrine that prioritization in the way that Riak works. The fourth area is that Riak is used by many people for different purposes with different object sizes, and most of our objects are relatively speaking on the larger side. So our average object size is probably somewhere between 8 and 12 kilobytes. But increasingly, as we use Riak, the most popular objects are growing in size, and so we have this kind of exponentially growing problem where the bigger an object is, the more likely it is to be requested, and the more likely it is to subsequently get bigger. So we're having to deal with bigger and bigger objects all the time, and we don't want to end up to go beyond limits of scale because of that. So we want to find ways of handling larger objects more efficiently. The other issue is observability. How do we know what is in our Riak cluster and what is going on with our Riak cluster? And especially as with no Basho being around, there's no kind of Basho support and operational staff to lean on. So it's important that we understand how to observe Riak directly. And the final issue is replication. We've had a number of issues with the Basho provided previously closed source enterprise replication features. So we've been looking at how we can improve those to make them more reliable in our use case. So cost, availability and durability. So when the original Spine program was started, so this was one that wasn't using Riak, using a sort of all-star relational database back in 2003, 2004. There was a lot of focus within the program and within the NHS as a customer on making this the service resilient to all kinds of disasters. So there were various public statements made about how the service would survive planes landing on data centers and this kind of stuff, and that created made sort of push various design decisions and this kind of stuff. And when we started on the Spine 2 to replace that service, is that one thing is we sort of set out and said, well, the good news is that planes do generally speaking land on runways and not on top of data centers. And that's not actually, you know, a very likely scenario, and it's probably not one we should be focused on. That's not to say that data centers aren't fully reliable. And you know, what we do know, and from a pattern of failures across data centers, is that, you know, things can make data centers go dark. So, you know, even if power is resilient, power can go offline. Data centers can get partitioned from each other. There can be catastrophic network failures in data centers, and there can be where there are other shared components, particularly storage area networks. We've seen those things go down across data centers. So, you know, we have to deal with data center failure. But yeah, the one that we're probably not going to have to deal with is the kind of disastrous, the data centers blown up type scenario. There are other more likely data center failure scenarios that we should be focused on. And of course, individual servers fail, you know, all the time. That's a constant thing, and they fail and come back without us noticing, and they fail and never come back, and fail to the point of destruction. So we have to be able to do that. So one of the things that we want to make sure was that in all these common data centers, all these common failure scenarios, you know, servers failing both temporarily and permanently, data centers going dark, power going off in a data centers partitioning from each other, that not only do we maintain availability of service, that we may maintain the durability of data, that such that data is stored in more than one physical node under all of these failure conditions. And that's something that wasn't the case in the previous system, is that it could, you know, kind of not necessarily automatically, but eventually recover from some of these failure scenarios. But after that recovery, you had a loss of data resilience for a period, and we wanted to make sure that we were still duplicating data even under all of these common failure scenarios. And so this actually works out of the box with Riak. But what we want to do is try and do this at a slightly lower cost. So at the moment, you can confirm that a write has definitely gone to 2 physical nodes in a cluster, but only through setting something called a PW value, which confirms that it's gone to 2 primary vnodes. Well, in many circumstances, when a write hasn't gone to 2 primary vnodes, it has actually gone to 2 physical nodes in the cluster. So if what we really care about is the fact that it's gone to 2 physical vnodes, not whether it's gone to 2 physical nodes rather than 2 primary vnodes, we would prefer that to make that the configurable parameter. So as we will say a write successful, regardless of how many primary vnodes it's on, as long as it's certainly on 2 separate physical nodes. So we want to add a write put parameter that provides that node confirms. The other thing is because we know that data centers can go dark, is that we may have sent a write to multiple nodes, but all those nodes could lose power at the same time. So if that write is only memory on those nodes, then we could still possibly lose that data. And so to get around that, in our current React configuration, we use a configuration at the back end to flush every write to disk. So it means that when we write to our React cluster, it gets written to 3 nodes, and there are 3 flushes that have to occur in order to complete that write. So that's fairly expensive, and we kind of get around that through some hardware magic using flashback write caches on the RAID controllers, and we'd like to make that those slightly cheaper. So we'd like to be able to be selective about how many nodes the write actually has to be flushed on. So, you know, it's probably enough from our safety perspective that it's been flushed on 1 node and not 3, if it's been confirmed that it's also been in memory of another node. So a combination of node confirms and selective sync, we hope we'll be able to reduce the availability and durability, so, the cost of that. So, so that's their configuration parameters, so write configuration parameters we're working on at the moment. And then the other thing is that there are some circumstances when you build and expand a React cluster when it can choose an inefficient allocation of resources around the cluster, and that can lead to more scenarios when multiple node failures can lead to a situation where individual writes aren't actually going to enough diverse nodes. So we've got some improvements to that claim algorithm that distributes those vnodes around the physical nodes to try and deal with that situation better, so that we have that's far less likely to occur as you expand and contract your cluster. So that's the first set of solutions that we've got, and most of those things is stuff that we've now got. In the case of the change to core claim, we've got some significant testing around it to prove that that works. In the other two, we got some basic testing done, but we're not yet ready. They're not yet release ready. So index inconsistency is the next area of problems. This is a particular problem when we're doing kind of force replace type operations. So when one individual node has gone beyond the state of repair. Let's say it's its RAID controller has died and that's corrupted a load of the disks and this kind of stuff. So we need to force replace that in the cluster. We can't do a neat replace whereby it slowly hands off its data. We have to kind of force replace, so elect a new node to be a member of the ring and get that to begin to learn about the old data from other vnodes across the physical cluster. And during that operation, we believe at the moment that 2i queries will potentially be inconsistent and won't give reliable results. So we currently have to perform that operation whilst the site is shut down to avoid that occurring. And that's fine, but it leaves us in a nervous situation that what would happen if we had a catastrophic failure on the site that was active whilst that operation is taking place. So we wouldn't be able to deal with that scenario. The other thing is that within a vnode on a physical node, is that internally can have entropy issues. So, when the level DB, that backend, writes a key value change and some index changes with it, that's written transactionally as one write operation. But then over time, the index values and the original object value will migrate to different areas of disk. So it's possible that we can lose the index values without losing the object value, and therefore we get incomplete results returned from a 2i query, and we don't really find out about it through active anti-entropy, which is focused on inconsistencies between object values. And then the final issue is with the short-term window that exists, whereby because we'll accept a write once it's been sent to 2 vnodes, there's then a very short window whereby if a secondary index query happens to choose a coverage plan that went to the 3rd vnode, not to the original 2 vnodes, then we'll get an incomplete query. That's kind of fine at the moment because it's a sort of arbitrary race between the query and the write anyway in our system. So it's kind of arbitrary whether you get the answer or not. But still, it'd be nice to sort of find ways to narrow the potential for that window occurring. So we can't necessarily stop these inconsistency windows, but potentially we can reduce the length of the windows as they occur. So the solutions that we're looking at here is we're trying to look for a way in which we can actually convert through configuration the status of a given node so that it won't participate in coverage queries. So if we know that a node is in a bad state, either because of a kind of internal entropy issue or because it's part of a force replace, it can be state itself to be outside of coverage plan, and therefore coverage plans will avoid it. So we'll avoid those inconsistency windows. The other thing that we're looking at is ways in which we can do more flexible queries to support anti-entropy. So rather than have a static database for anti-entropy, which exists in Riak at the moment, we can actually dynamically query Riak. So we can do things like query Riak to say, is a coverage plan on one offset giving the same answer has the same Merkle tree for an index as a coverage plan on another offset, and perhaps does the coverage plan on a given offset if you do a Merkle tree of that index, does that agree with what the indexes should look like according to a coverage plan that was run across the objects? So finding ways in which we can more flexibly compare and detect issues of inconsistency between indexes and objects is another area that we're working on. And then the other thing is when we want more consistent results, currently we use G sets rather than 2i queries, and you know, also we make some use of sets as well, so the actual CRDT sets within Riak. And so we want some ways in which we can actually prove that there's no entropy that's been introduced whereby the content of the G set or the set has drifted from the content which it should be based on the attributes of the objects. So we're looking at some flexible anti-entropy queries there. And the general mechanism we're using for these anti-entropy queries is one we're calling tic-tac trees. And this is something that's implemented in my level ed backend, which is a pure Erlang key value store designed as a React backend. And this does Merkle trees, just as the existing React database does Merkle trees. But they're special Merkle trees that they don't have the cryptographic strength of the normal Merkle tree, but they're measurable and you can grow them incrementally without needing to know the full key space in order to create them. So it makes them much cheaper to produce in folds and makes it possible to merge across folds, merge trees across folds as well. And it gives anti-entropy trees that can be of fixed sizes, and there's fixed sizes that need to be transferred across the wire. So they have some interesting characteristics, and we want to try building those directly into Riak. And so we can use folds for those tic-tac trees in lots of interesting and different ways. The other thing is prioritization. So secondary indexes and other things use a thing called vnode workers. And in a kind of normally configured React cluster with a normal ring size and a normal distribution of vnodes, you have about 100 vnode workers per node. Well, you know, 100 vnode workers, you know, we have probably, you know, we only have 6 disks on every node. We only have 12 CPU cores. So they're more than capable of saturating all the load on the node, so all the capacity of the node. So at the moment, you know, background jobs and 2i queries tend to use these vnode workers, you know, we have no way of stopping that from bringing the whole cluster to a halt. Some of the other more expensive jobs have some additional locking and throttling schemes on top of that, but you know, kind of every job tends to have its own locking and throttling scheme within Riak. And so we want to make sure that in the context of the background jobs and in context of 2i queries using vnode workers, we can maintain priority for gets and puts, because you know they're the primary purpose of our React stores. So there's 2 things that we're trying to do here. One of them is again the level ed backend, which the primary distinction between level ed and level DB is it separates out keys and values, so that rather than having the key stored together with the value, the key is stored with the metadata and the value is stored separately. And so the merge tree that's created, the stuff that's ordered by key, contains only the key and metadata, so that when we scan that merge tree, we can perform a scan that's you know, equivalent to the size of the combination of all the keys and the metadata, not equivalent to the size of all the keys and the values. And for us, with large objects, that's a big difference. So it's much easier for us to have our key store that contains the index entries and the key and metadata in level ed, you know, fully covered by memory, you know, prioritizing the page cache, that kind of stuff. So we can actually make the job of scanning over that much cheaper. And because the metadata tends to contain all the information that we're interested in, or the 2i key information for all these types of jobs, we can actually make these jobs fundamentally much cheaper. So the risk associated with one of those jobs overloading the service is reduced. And then the other thing is we're looking at is introducing one or more node worker pools. So rather than having a separate worker pool for each vnode, have a separate worker pool for each physical node. So the initial implementation we've done for that is one whereby we have a pool of only one worker per node, and then all the kind of deferrable background jobs, such as AAE tree rebuilds and other such things, are sent to the node worker pool rather than the vnode worker pool. And then we know that, well, that's only running on one process, and so should only consume one CPU core and effectively one disk and this kind of stuff. So we can make sure that the majority of our work is protected from that. And we're thinking about how we can potentially have something like a very constrained pool for low priority work, a small node worker pool for kind of mid priority work that we don't want to be slowed down by the very low priority work, and then reserve the vnode worker pool only for stuff that definitely has to happen immediately. So we have Level Ed is working and available now, but still needs improved testing, particularly around sort of fuzzy testing, quick check type testing, before it's ready for production environments. And there's some initial rough code for the node worker pool stuff that we've done, and some initial volume testing of that to show that that has potentially some small positive difference there. So that's still very much work in progress, that work. Bigger objects, as we said, more popular objects are getting bigger all the time, and the bigger the object is, the more likely we want to access it, and that causes some secondary issues as well. Particularly in Level DB, because the key is stored with the value, we found that Level DB workloads can get dominated by write amplification as those values are merged down the merge tree and constantly have to be rewritten. That becomes a dominant factor in disk busyness. The fact that the value has to be read 3 times for every fetch, even when the value is the same across all 3 vnodes, creates extra disk load and extra network load, and some interesting problems like TCP incas. For where we use CRT sets, we're having to manually shard those sets at the moment. And we find that large objects has commonly been an issue with replication as well. So often we've seen replication failing, and often when we've seen it fail, it's been associated with a large object. So really our requirement is that we know large objects are going to make things harder. How do we mitigate the risks of performance decay and increasing performance decay as objects continue to get bigger? So part of the answer is going to come through the Level Ed backend again, so where the merge trees are going to be keys and metadata, not values. That write amplification is reduced dramatically. The other thing as part of that is we're looking at changing the get FSM so that rather than asking each backend to give a get response, comparing all 3, seeing that by and large that all 3 are the same, and then discarding 2 of those responses, what we're changing the get FSM now so that it can actually send 3 head requests first that only in effect return the key metadata. They can do the vector clock comparison, and in a normal scenario they then only need 1 get request fulfilled. So rather than reading the object 3 times from disk, we only read it once from disk. Rather than transferring it 3 times over the network and getting the incast risk, we transfer it only once over the network. And then potentially also we can open up those head requests so that they're accessible from the application as well. So situations where the application is perhaps only interested in whether or not an object's updated since it last read it, it can do a head request rather than a get request, and avoid pulling the whole object altogether, and avoid the very nasty situations that can occur, particularly if you have sibling explosion, when objects become unreadable and then become undeletable because you can't find the vector clock because you can't get it. If we have a genuine head request support end to end, we can risk some risk there. To resolve the issue of having to shard sets at the moment, we need some of the work that has been worked on at Basho with Russell Brown around big sets, which brings into operations on the back end that are per subkey rather than require the fetching and updating of the whole set object. So that's stuff that we've not made much progress on yet, but we do think that with a pure Erlang backend, we may well be able to, such as level ed, we may well be able to make faster progress with some of that big set work going forward. And then the other thing around replication, one of the areas where we believe replication has a problem with big object is, as it tries to manage its multiple queues for distributing the sending of those objects across the network. The current replication code has its own queue mechanism. So one of the things we're looking at is to say, well, there is already a queue system written in Erlang called RabbitMQ, and will that actually handle larger objects better? And will that make it easier for us to manage multiple queues and work around situations whereby replication gets blocked by big objects? So Russell Brown has done some work on that, and he now has a fully working prototype for replacing Riak Enterprise real-time replication with a RabbitMQ based replication code with multiple RabbitMQ instances, one on every physical node. Observability. So when you want to know what's in your React database, the kind of traditional React answers we say, well, you put it in there, so you tell us what's in there, and the reality is that we don't feel that's a particularly satisfactory answer. So we want to be able to actually make observations about what's in our React database, what's the average object size, actually precisely how many objects have we got in there, what would be a histogram of object sizes, how objects currently have things, this kind of stuff. And there's no way of telling that at the moment, so we want to provide an answer to that. I think there's a lot of processes in React, particularly around, for example, active anti-entropy rebuilds that have a habit of logging to tell us they finished, but not logging to tell us they've started. So you can be in situations whereby you're seeing poor performance in your cluster, but the thing that's causing the poor performance didn't log at the start, so you don't know that it's going on at present. So we want more of observability of what's going on, particularly with background processes. Then the other thing as well is that Riak is written in Erlang, and so there are various things we can do in Erlang to observe what's going on into it. And until that goes into the back end, and if we're using the level DB backend, that's entirely written in C++. So we need a different set of observability tools to what's going on in the back end, and so we'd like to sort of break down that barrier. And even in the Bitcast backend, which is allegedly pure Erlang, a large part of the logic is still written in C. It's niffed out, particularly the in-mem part of that. So we still don't necessarily have full observability from an Erlang perspective about what's going on. And then the other thing is that sometimes we want to know something functionally about all our objects in the cluster, and there was a MapReduce capability in React that was intended to help you with that kind of thing, but that MapReduce wasn't very well controlled, so it was very good at dealing with back pressure to stop you from overloading the MapReduce query, but not from consuming all the resource in your cluster and stopping other work from going on. So we want a neater way kind of writing reports, more functional reports around the content of objects across the cluster as well. So our basic requirement here is to be very informed of contents and activity. So one of the things that we're looking at the moment is optimized folds over object metadata. So the same mechanism that we're putting in for doing different folds for anti-entropy purposes is we realize we can use those same folds for observing the contents of the database, both non-functionally in terms of sibling counts and size of objects and counts of objects and this kind of stuff, and also functionally, if we can load some key information into object metadata, we can use those folds. We're also looking at sort of sampling folds, whereby because we know the load is evenly partitioned, perhaps we don't need to query all the load, we just need to query the contents of one vnode, and we can extrapolate out from there. And to do this kind of stuff, we want folds that have accumulators that have things other than lists. So if the fold can only produce a list, then that means we still maybe have to stream a lot of data back to the application. And if actually all we're interested in a count, then the fold should be able to produce just a count. And if what we want is a Bloom filter to produce or a Merkle tree to produce from the fold, that's what should be producible. So looking at doing that. And really the answer to some of our observability problems with backends is, again, the level ed store, given that it's written in Erlang, allows us to have more joined up observability end-to-end, and make it easier for us to understand what's going on end-to-end, because there's a common language across all the code. So that work, I've mentioned the sort of status of level ed before, and these different type of folds and that kind of stuff, that's very much work in progress at the moment. I was hoping to have something ready and publicly available on that roundabout now. It's probably a week or two away, but hopefully if we can get a slot at the Bet365 workshop in Stoke, I may have something that I can present working on these different types of folds then. And finally, replication. Originally, replication had been our big focus because that was seen as the barrier to us going to having a fully open source Riak. And with great thanks to Bet365, we no longer have to make that our focus, because soon, replication should be available to everyone, open source. But there are some problems with replication, and our biggest issue with replication is that the current enterprise replication code really only works if you've got common ring sizes between your two clusters. And at some stage, in order to scale, you're going to need to change your ring size, and the internal ring size change code in Riak was never something that was recommended for you without a lot of hand-holding from Basho. And with no Basho being here, it's not something we want to look at again. So the easy way we think of changing ring size is to have replication that works independent of ring size. So if you did want to change your ring size, you just start a new cluster and asynchronously replicate through to that cluster which has a different ring size, get the two in sync, and then pass your load over to that new cluster. And so we want replication that works like that. Ideally, replication that doesn't depend on least keys, doesn't have isn't a bandwidth hungry. And then the other thing as well, when we look to compare the state of two clusters, Riak only ever compares the whole state at the moment through its enterprise replication process, where actually what we're probably most interested in and what's most likely to occur as a gap is recently sent writes. So we want to be able to make things more efficient by separating the job of comparing recently received writes from comparing all the writes that we received. So that's another area that we're looking at. And generally speaking, replication code is quite complicated, and we think potentially that could be made simpler, potentially by introducing third-party products. And for most of the NHS, we're only really focused on bidirectional replication, and ideally we want it currently to be controllable externally, so that we don't have to rebuild Riak if we want to change how we schedule replication and that kind of thing. So as mentioned, Russell Brown's work on Rabble, that's out there, and I think provides a less complex replication mechanism, and potentially using things like topic-based queues and multiple subscribers and this kind of stuff, it may well open up in a simpler way different replication approaches. I've talked a bit about tic-tac Merkle tree folds, and we see that as being a big part of how we would compare state of clusters. And we're looking at how we can get that to work so we can compare the state of two Riak clusters, but also potentially the state of Riak cluster and the same data stored in a different database as well. So rather than making the job of synchronizing two databases require a whole load of specific code written into Riak, as is at the moment with comparison with Solar, is that we can make that a more generic, externally available feature, and people can potentially compare state of a Riak database with any other database of their choice, as long as that database has got stored the vectors and clocks in it as well. And then the other thing we're looking at is objects, giving objects a self-expiring index, so an index that will disappear after a few hours after that index was written, but an index that's ordered by last modified date, and that we can run these Merkle tree folds over, so we can do very quick comparisons of, can you tell me, have you both sides received all the changes that were made you know, in the past hour, much quicker than comparing the whole state. So that's what we're working on at the moment, and all of that stuff is kind of a lot of stuff in theory, and some kind of prototype code, but nothing yet ready for production. There's rather a lot that I've gone through there, and hopefully it kind of wasn't too confusing just hearing me talk about it. You know, this presentation is available online, and you can contact either myself or Russell that's been working on this. Also, Dr. Raman Sen, that those from the React world may not be familiar with. He's the lead from the NHS internal team that's been working on this, and he's also been writing a number of these features as well. And so we should be available going forward. And I do hope for those that are able to attend the workshop in Stoke, that we'll get a chance to present some of these ideas and solutions in more detail, and so you can get ask more detailed questions and get a more detailed view of them. And everything that we do is that we are going to, you know, put out long reads on GitHub explaining them, and we'll advertise them on the Slack channel and the mailing list. It's part of the definition of the work packages between the NHS and the people working in React work, that everything we do will be available open source. So there's nothing we do that we won't publicise. So there will be more information becoming available on these things going forward. So Martin, back over to you, I think.
Martin, thank you for a very inspiring talk on Riak, which I thoroughly enjoyed, and I'm sure members of the audience did as well. I'd like to formally open the question and answer session, which we promised. We have a small amount of time available. We will answer your questions in the order in which they were received, and we will try and answer as many questions as we can. So Martin, to dive straight into that, one of our audience members is interested in knowing a bit more about what features specifically would you personally like to see added to Riak going forward?
So me personally, rather than the sort of NHS as a whole, I think that the big thing that I've always wanted in Riak is more flexibility around 2i queries in terms of the functions that can be passed in and the accumulators that can be used. So I kind of contributed towards a feature that exists at the moment, which is the ability to pass regular expressions into 2i queries. I think this is an underused thing. I do think, as a general rule, there's some very interesting things in Riak that in the past they had side effects in production, and the answer was sort of not to use them. So, you know, 2i was kind of discouraged. The use of it was discouraged to a certain extent. MapReduce was discouraged quite a lot. So I do think that there's some stuff that we can achieve with perhaps, you know, fairly limited work by actually making those features more usable in production and slightly more flexible. You know, we can, you know, yeah, the work on MapReduce in particular from Brian Fink was really, really good work. And it's kind of sat there unused because people are recommended not to use it. And rather than have to sort of create a whole new interesting and complex world, it would be great if things like that we could actually begin to make use of by trying to focus on the reasons why it was recommended not to use them in production in the past. So I think there's some quick wins there, but you know, we've built some really powerful things using second 2i queries. You know, we've written our own query engine and this kind of stuff. I think there's probably some stuff. There's probably some stuff other people could do there, and that would perhaps avoid the complexity of doing things like integrating with Solar. And I think that's the area that I'm most personally interested in.
Martin, thank you for that. We'll move straight on to the next question, just to try and honor as many of these queries as we can. One of our audience members is interested in your comparison between Riak and other NoSQL options that you may have experience with. Obviously, this is the assumption is you have some experience with other NoSQL options. How would you compare them?
Yeah, I mean, most of that, experience came from the point when we were kind of evaluating between them, and obviously we've refreshed that evaluation recently to make sure that the right thing for the NHS is to continue with Riak. And I guess the primary areas where we felt Riak stood out was the stuff that I mentioned before about the focus on data protection, on conflict. And the flexibility about how to handle conflicts, and the automatic data types and this kind of stuff. It really works well for us, because we are focused not just on availability, but on long-term durability of the data, and the need never to lose any history of what's gone on. So that tends to work better for us, and that tends to be a feature that's missing from other NoSQL databases that may scale out better and do other things better. The other thing is the automatic recovery from failure. And so what we found, we've had other NoSQL products, is that they handle failure well, but then require an admin process to get nodes back online and this kind of stuff, and don't necessarily deal with nodes flapping up and down as well and this kind of stuff. So kind of intermittent failures and this kind of stuff. Where we found in operations, React is very, very efficient for us and requires very little attention, and that saves us a lot of money. It may well be that other things that have other operational features, but certainly our experience of React is that from an operator's perspective, aside from the things we've highlighted around observability, it's extremely low maintenance, and it also, and I don't know how this compares to other NoSQL clusters, NoSQL databases, but it runs very, very effectively on very low cost hardware. So low speed CPUs, slow disks and this kind of stuff. We can still get significant throughput out of our React databases, and because we don't have to recover from failure quickly, we can deal with multiple nodes failing. We can have low cost hardware that doesn't have fast response time on failure, so we don't have to get a man and a van out quickly. So our hardware annuity prices have just crashed, and we make enormous savings on hardware compared to using previous databases that we tried.
Wonderful, Martin, thank you for that. I think that's a very comprehensive answer, and in fact you've kind of tied into the following question that we received, and I'll just ask you to sort of expand on that a bit. One of our audience members is basically asking, in terms of operational ease of life, how would you compare Riak with the kind of more mainstream traditional databases? Could you give us almost an order of size or a kind of concrete, practically numerical comparison in terms of savings and ease of use?
Yeah, I mean, if we compare to the previous incarnation of Spine, we had there was a team of full-time DBAs required to keep the system going, and that was without sufficient rehearsal of various disaster events and this kind of stuff. And I know we have a log of activity of who's logged on to the database and this kind of stuff, and we can often go 4 or 5 weeks without anyone connecting to a database, let alone anyone having their full-time job to look after the database. So we build systems for in government that last a long time. The time in development is relatively low compared to the time in operations. We'd expect this system to last at least a decade. So saving in manpower is huge, and it's a cost that really increments for us. The hardware annuity charge difference is probably 2 orders of magnitude that we've saved there. It's an enormous difference, and probably we're already at the stage where we've accrued a saving of over £10 million compared to the previous solution. just in database infrastructure and operation costs. So it has made a big difference compared to having what was at the time the best practice enterprise SQL solution.
Martin, thank you for that. I think that sounds fantastic, and I think we'll all agree the NHS can redirect the savings and use them in a different area to our benefit, to the benefit of everyone using the system, really. So we have the following question, which I think is quite interesting, but I think we'll need to post it over to you because it involves a couple of formulas. So we'll just do that now. You should be able to see the question in your chat window, and perhaps you can kind of quickly summarize it and then give us your answer.
Okay, so this is about the combination of gets and heads. So so I did look at that. So whether we could do one get and n-1 heads rather than n heads and one get, and the answer is quite complicated. So it does make it is right by doing n heads and one get, which we increase latency in the system. And one of the problems was, I think, if I recall correctly, was how we would deal with how we were going to deal with mixed backend clusters. So clusters where we'd only rolled in some nodes on level ed and some nodes on level DB. So that was in the consideration. I probably can't recall the whole argument that I had with myself at the time, but that's definitely something I considered. If that's from Heinz, I think what I'll do is I'll try and answer that in a kind of written blog post in a bit more detail and take some time to think about the precise reasons. Because I did think about maybe changing the FSM, so it was more like the put FSM, so it actually went to one of the nodes that was one of the owners, and that would do a local get, and then the two heads to compare it with, and I decided not to do that, and so I'll try and give some more detail on that.
Martin,
offline.
Thank you for that, and we'd also like to thank our friend Heinz, who asked the question. And as you've probably heard, Heinz, Martin will try and provide a wider answer, perhaps even in form of a blog, which is fantastic. So, Martin, I guess, with Basho stopping effectively the running of their business and stopping trading, the big question in everyone's mind is the longevity of Riak and how Riak sort of moves forward. You've mentioned that the NHS believes in Riak and that people like Bet365 and other large corporates using Riak believe in the database and in its future. Can I just ask you, is the commitment to using Riak in the NHS a long-term commitment?
I mean, I think it's definitely a medium-term commitment. So it's definitely a commitment we've made in terms of number of years. We won't be moving across soon. When the sort of news first came out about Basho, we did a reassessment and we said, okay, events have changed. Should we be moving? And the answer was no. There was a good reason why we chose Riak in the first place, and that good reason remains true. And also, given our experience, because we worked closely with Basho, because we had access to source code and that kind of stuff, is we have a degree of confidence that within the NHS and the partners that the NHS works with, we have enough capability to actually maintain it going forward, even if there's no support from other third parties, and if the community doesn't form and this kind of stuff. So I think for now there's certainly no ongoing project to consider changing it. And so it's, and we're unlikely to reconsider again, in the next year or two. But every technical decision we have is something that will be subject to review should events occur. So, I can't guarantee you we'll still be running Riak in 10 years' time, but there's currently no intention to not using Riak. And given, that there is a certain amount of of drag when you've got a billion odd objects in a database. It's risky to change, so we would need good reason to move away from Riak. And at the moment, we've got good reason to stay with Riak. So it's probably the opposite end of the spectrum for us moving.
Thank you, Martin. The time has almost run out on us, but I would like to ask one final question that we received from Andy. Andy is asking, have you investigated Delta-based CRDTs at all?
So I haven't, but I'm pretty sure Russell Brown will have investigated that. So I'm probably not in a position to answer around that. At the moment, we're just focused on CRDTs, on using the kind of simpler forms. Yeah, Delta-based CRDTs, I'm sure is something we'll look at. I guess I'm a bit, because I've not looked at it myself, I may be unclear on the terminology and whether some of the things that we're doing with kind of single key-based operations are equivalent to those Delta-based CRDTs, or whether there's something altogether. But Russell's our man on that, and so I would suggest popping him a question on Slack around that, and he will no doubt be inform you much better than I can.
Wonderful, Martin, thank you for that. I'd just like to mention in regards to the penultimate question I asked you, so in regards to the longevity of Riak, I think it's evident that NHS is obviously investing a lot of trust and a lot of work in Riak. Bet365 is doing the same, other companies are doing the same. I'd just like to say that with the unfortunate demise of Basho, we here at Erlang Solutions believe in Riak too. We believe in the product, we believe in its future. And as we have worked with Basho very closely over the last several years, we are in a position of deep expertise, both in Riak and obviously in terms of Erlang and the Beam in general. So what we now do is provide very extensive Riak support. If you're using Riak, if you feel you need support, please talk to us. We can provide anything from working hours to 24/7 coverage. In other words, you're not on your own, and Riak is continuing to be supported and will hopefully continue to be developed as a product, and that's something that we will be working on with our partners and customers. So just to say, first of all, Martin, thank you so much for an incredible webinar that I really enjoyed, and from reactions and feedback I can see others have as well. I'd just like to say and finish by saying everyone is welcome to obviously look at our website following this webinar. We will be posting the recording of the webinar on our web pages, so you'll be able to take the entire session there and obviously see that again if you'd like to. Many thanks to our audience for joining us today. We will send you a very brief survey to make sure we capture your feedback from today's webinar. If you have any questions remaining, then obviously feel free to email myself. Martin has left his details as well. We'll be happy to answer any queries you may have. So thank you all once again, and we very much look forward to seeing you on our next monthly webinar.
Thank you.